Or you are in mute.
Good morning, students. Good morning. So in previous class, we discussed about the preparation properties, applications of polyvinyl chloride, Teflon. Two polymers we discussed. Today we'll discuss about the Bakelite and the preparation of Bakelite and Nylon 66. So how to prepare the Bakelite and how to prepare the Nylon 66 and what is the properties and what is the applications of Bakelite and Nylon 6 that we'll be discussing today. Okay, and one more topic is there, biodegradable polymer. Then half of the chapter is completed. So maximum on Monday we'll finish these topics. So preparation properties and applications of polyvinyl chloride, Teflon, Bakelite, and Nylon 66. Already we discussed the PVC and Teflon. Today we'll discuss about the Bakelite and Nylon 66. So yesterday class again, once again we'll discuss about few minutes. So polyvinyl chloride we prepared from vinyl chloride. Vinyl chloride polymerization, that we are getting the polyvinyl chloride. So properties and application of the properties, the polymers having the maximum properties, resistance to sunlight, moisture, acid, alkali, etc. This is a preparation of polyvinyl chloride and the polytetrafluoroethylene. Polytetrafluoroethylene is prepared by tetrafluoroethylene under the polymerization in presence of benzyl peroxide and peroxides. Then we are getting the polytetrafluoroethylene. These are the special properties. Teflon also like fluorine. This more number of fluorines are present, highly electronegative atoms. There are strong attractive forces responsible to high toughness, high chemical resistance towards to all chemicals except the alkali metals and hot fluorine. So uses, these are mainly used in making seals, gaskets which withstand high temperatures. It is also used for insulation of electrical items and for making non-stick surfaces coating, particularly for cooking utensils. Teflon used for insulating material like motors, transformers, cables, wires, fittings, etc. So this is about the preparation properties, applications of PVC and Teflon. Now today we'll discuss about the Nylon 66 and the Bakelites. So how to prepare the Nylon 66? Already we discussed the the preparation, how to prepare. So this Nylon 66 is prepared by hexamethylene diamine, hexa H2N CH2 taken 6 times and NH2 hexamethylene diamine is reaction with adipic acid, n number of hexamethylene diamine and n number of adipic acid, double bond O, CH2 taken 4 times and C double bond O, OH. So here NH2 is then a hydrogen, now adipic. Undergo condensation formation minus water molecule image takes place. HNCH2 taken 6 times, C double bond O, sorry. NHC double bond O, CH24, C double bond O taken in times. So this is called as nylon 6, 6. So this is the preparation of nylon 6,6. So nylon 6,6, how to prepare nylon 6,6? Nylon 6,6 is the prepared by condensation polymerization. Condensation polymerization means the removal of small molecule takes place, then strong covalent bond is present between the carbon to carbon. But this is the linear molecule. The nylon 6,6 is a linear molecule, but it having the strong bond formation takes place. Why? Because formation of amide bond is the NHC double bond O bond is called as NHC double bond O bond is called as amide bond. This is called as amide bond. So this is a preparation of nylon 6,6. Nylon 6,6, how to prepare nylon 6,6? Nylon 6,6 is nylon 6,6 is prepared from hexamethylene and adipic acid, undergo condensation polymerization. Then we are getting the nylon 6,6. Why we are called as 6,6? Why? Because you see in the hexamethylene how many carbons are there? 6 carbons are there. In adipic acid, how many carbons are there? 6 carbons are there. 4, 5, 6 carbons are there. So simply we are called as nylon 6,6. So this is a preparation of nylon 6,6. So nylon is a polyamide resin containing recurring amide groups NHC double bond O in its structure produce the copolymerization of diamine with the acid. So why? Because the monomers are different types, so there is copolymerization, but that is undergo condensation polymerization depending on the number of carbon atom. Diamine, dioxide, there is different types of nylons like nylon 6,6, nylon 10, nylon 6, etc. are there. So where the first number of indicates number of carbon atoms in diamine, and the second number indicates the number of carbon atoms in diacid. Just now we discussed now. So nylon 6,6 is prepared condensation polymerization of adipic acid and hexamethylene diamine in absence of air. In absence of air, it is prepared by condensation polymerization. The adipic acid is reaction with hexamethylene diamine. Then we are getting the nylon 6,6. So this is the nylon 6,6 adipic acid, hexamethylene diamine, and prepare the nylon 6,6. So students, once you write down the reaction, make it fast, all of you. All the students write down the reaction, that chemical reaction, nylon 6,6 preparation. Okay. Rule number 2. Rule number 2. Rule number 2. మా 2 వినపడతలేదా? Rule number 2. Rule number 10. 10. వినపడతలేవానే?
వినిపిస్తుంది సార్.
రూల్ నెంబర్ 2 బిలో ఎవరు? అమ్మాయి ఎవరు? అబ్బాయి అమ్మాయి ఎవరు? రూల్ నెంబర్ 2. Today rule number 2 is absent. I make it as absent to that person. Who is the that one? He is not responding. Rule number 10. Rule number 10. Rule number 2 and rule number 10.
హలో సార్.
ఏమే చెవులు వినబడతలేవా?
సార్ ఇది రావట్లేదు సార్ నాకు అన్మ్యూట్ చేసుకోవడానికి. ఎందుకు
నేను చేస్తున్నా కదా, అన్మ్యూట్ చేస్తున్నా నేను చేసినా కదా. నిన్న హోంవర్క్ ఏమి ఇచ్చా నిన్న
సార్?
ఆన్ యువర్ వీడియో.
సార్ నాకు వెబ్ క్యామ్ లేదు సార్.
ఏమున్నది మరి?
నేను కంప్యూటర్లో వింటున్నాను సార్.
కంప్యూటర్లో వింటున్నావా?
ఎస్ సార్.
కంప్యూటర్లో ఎట్లా వింటావు వెబ్ క్యామ్ లేకుండా? ఇప్పుడు నువ్వే వింటున్నావు అని గ్యారంటీ ఏంది నాకు? నువ్వే అని
సార్?
నువ్వే అని గ్యారంటీ ఏందయ్యా? ఐ విల్ మేక్ ఇట్ యాజ్ ఆప్షన్ టు యూ. రూల్ నెంబర్ 2. రూల్ నెంబర్ 2 వినబడతలేదన్నా? రూల్ నెంబర్ 2. రూల్ నెంబర్ 9.
ఎస్ సార్.
ఎస్టర్డే హోంవర్క్ చేసావా?
ఎస్ సార్.
షో మీ ఆన్ యువర్ వీడియో.
పీసీలో కెమెరా లేదు సార్.
పీసీలో లేదా? నేనైతే రూల్ నెంబర్ 9. ఐ విల్ మేక్ ఇట్ యాజ్ 1 week absent to you. You 3 members. 34.
సార్
ఎస్టర్డే హోంవర్క్ చేసినావా?
చేయలేదు సార్.
ఎందుకు?
అంటే నిన్న టెక్ టాక్ వీడియోస్ కొన్ని మిగిలిపోయాను.
టెక్ టాక్ వీడియోస్ హోంవర్క్ ఎవరు చేస్తారు?
సార్ రేపు చేసి చూపిస్తా సార్. అంటే మండే చూపిస్తా.
నాకెందుకే? అంటే నేను చెప్పినప్పుడు చేయాలి కానీ నీ ఇష్టం వచ్చినప్పుడు చూపిస్తాను. And I will make it to all students. I will make it as absent today for chemistry. Who have done the homework? Homework చేసిన వాళ్ళు ఎవరు? 65.
సార్
65.
ఎస్ సార్.
చూపించా ఒకసారి హోంవర్క్ చూపించు నాకు.
సార్ కనిపిస్తుందా?
ఒక్క నిమిషం.
సార్
కనబడట్లేదు. 65 ఏది అసలు ఎడబెట్టినా? ఏంటిది అదంతా బ్లర్ వస్తుంది. ఏం కనబడట్లేదు అసలు వీడియో.
1 second.
కనబడట్లేదు కరెక్ట్గా. రూల్ నెంబర్ 7. రూల్ నెంబర్ 7. 44.
సార్
ఓకే 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 అమ్మా. ఓకే 7. ఓకే
సార్ 44 సార్.
44 ఎవరు? చూపించు నోట్స్.
ఎస్ సార్, 1 minute.
remaining students write down the reaction. కనబడట్లేదమ్మా.
సార్ 1 minute సార్.
65. ఓకే 65.
ఓకే సార్.
సార్
ఓకే అమ్మా. ఓకే వెరీ గుడ్. వాట్స్ యువర్ నేమ్?
శృతి సార్.
శృతి. ఓకే. 12. రూల్ నెంబర్ 12.
సార్
ఎవరు?
నేను అన్సిక్ సార్.
అన్సిక్.
ఐ డిడ్ సార్ హోంవర్క్.
షో మీ వన్స్.
1 minute.
Make it fast now. You have to complete the homework. That is important questions. Many times I said na. Sick. Okay, good. Very good. Nice. Good. Stop. Very good. Hansik. Good. 50. Remember?
I did sir yesterday only.
Okay, very good, very good. 50. Okay. 49.
Sir,
49. Gauran.
show sir 1 minute.
Okay, no need. I don't want to ask you. Why? Because you're done, I think. 50. Okay, okay, good. So remaining students, you have to write the homework. I will check on tomorrow, Monday. Okay. Don't waste your time. So now coming to our topic, that is the preparation of nylon 66. Nylon 66 is prepared by adipic acid and hexamethylene diamine. Then we prepare the nylon 66. So adipic and in between the bond, amide bond is formation takes place. That amide bond, by using the condensation polymerization, we prepare the nylon 66. The monomers are the hexamethylene diamine and adipic acid. Preparation. So this is also one of the preparation of nylon 66. The properties of nylon 66. Students listen. The properties of polymers are resistance to sunlight, moisture, acid, alkali, corrosion resistant. These all are common, but except this one having some special properties. So the structure of nylons are linear, that permits side by the side alignments. So moreover, the molecular chains are held together by hydrocarbon atoms. So the nylons having high crystalline, which impact high strength, high melting points, elasticity, toughness, and aversion resistance, and retention of good mechanical property up to 125 degrees centigrade temperature. They are polar polymers. They have good hydrocarbon resistance. So these all are the properties of nylon 66. So main properties are resistance to sunlight, moisture, acid, alkali, and resistance to corrosion. Resistance to corrosion, having good mechanical properties and electrical insulating properties. It having it contains a long chain hydrocarbon atom, linear structure. So this impact high strength, elasticity, high melting point, toughness, abrasion resistance, etc. So these all are the properties about the nylon 66. Applications. So this the major applications is in textile industry. So these nylon 66 are mainly we are used in textile industry. There is elastic model garments are there. In that purpose we are using the nylon 66. So because of the high thermal and abrasion resistance, nylons are used in mechanical engineering like gates, bearings, machine parts where greater friction is there. Flexible tubbing for the conveying petrol, etc. Are made from nylons. Nylons are used for electrical insulators, and nylon is used for making of tire cords. And nylons are used for automobile industry and telecommunication industry for making radiator parts and coil formers respectively. So these all are the applications about the nylon 66. So nylon 66 are major role in nylon 66 textile industry, and these are mainly by using this one we are prepared the gears, bearings, emission parts, and used in electrical insulators and making tire cords, and making in the automobile industry and the telecommunication industries, we are use the nylon 66. This is the preparation, properties, and applications of nylon 66. Now next one is you see these are the nylon fabric, nylon plastic, so nylon rolls.
Sir, also we'll have nylon ropes. No, sir, we'll
Yes, rolls, ropes.
ropes.
Yes, nylon ropes. Any more application? Anyone know about any more application for nylons? All of you, once you read the applications of nylon 66. So next one is the Bakelite. So this Bakelite is mainly we are prepared from phenol and formaldehyde. So when the phenol is reaction with formaldehyde, so that we prepare the phenol formaldehyde, that is polymer, that is simply called as Bakelite. First of all, you see students listen, see carefully the structure of preparation of Bakelite. So you see first phenol OH. So this phenol, when reaction with 1 mole of formaldehyde HCHO, that form as a monomethyl alphenol. That form as a OH CH2OH. So when phenol is reaction with the 2 moles of HCHO, that form as a dimethyl alphenol. Dimethyl OH. Sorry students, small disturbance. So 1 mole of formaldehyde that form as a monomethyl alphenol. This is the monomethyl phenol. 2 moles of formaldehyde that form as a CH2OH. You observe the reaction CH2OH. So this is the dimethyl phenol. Same phenol when reaction with 3 moles of HCHO, that form as a trimethyl alphenol. That form as a trimethyl alphenol. OH CH2OH and CH2OH CH2OH. So this is called as trimethyl phenol. So this monomethyl alphenol, dimethyl alphenol and trimethyl alphenol undergo polymerization that form as a novolac. That form as a novolac. So CH2 OH CH2 taken n times. This is called as novolac. You see students. So phenol is reaction with formaldehyde that form as a monomethyl alphenol, dimethyl alphenol and trimethyl alphenol. So this monomethyl, dimethyl and trimethyl alphenol when undergo polymerization that form as a novolac. So this novolac undergo polymerization and again undergo condensation polymerization. Then we are getting the Bakelite. All of you, what you can do, you have to write down the reaction, these reactions, make it fast. First, you write down these reactions only. Okay, phenol, 1 mole of formaldehyde, monomethyl phenol. Phenol, 2 moles of formaldehyde that form as a dimethyl alphenol. Phenol reaction with 3 moles of formaldehyde that form as a trimethyl alphenol. Then this mono di trimethyl alphenol when reaction with each other that form as a novolac. How the novolac formation takes place, let's discuss now. So once you observe phenol, 1 formaldehyde that form as a monomethyl alphenol. Okay, you have done these reactions first of all. Phenol, formaldehyde that form as a monomethyl alphenol. Phenol, 1 mole of formaldehyde that form as a dimethyl alphenol. 1 mole of formaldehyde that form as a trimethyl alphenol. This monomethyl alphenol or dimethyl alphenol combine with each other. Removal of small molecule takes place, undergo condensation polymerization that form as a novolac. The structure of novolac is this one. Now this novolac, you see student, this novolac is there. Now this will undergo polymerization. Then we are getting the Bakelite. The structure of Bakelite is like this. You observe. This is the structure of Bakelite. So how to write the structure of Bakelite? Here I am writing here. You see. OH, CH2, OH, CH2, this is called as Bakelite. This is structure of Bakelite. Okay. So when novolac resin is further heated in presence of formaldehyde producer, that is hexamethylene diamine curing agent, that is a reagent, a cross-linked polymer Bakelite can be obtained. So that is called as Bakelite structure. That is a Bakelite. The properties of Bakelite, it can be quickly mold, and very smooth molding can be obtained from this polymer. And Bakelite molding are heat resistance and scratch resistance, and resistance to sunlight, moisture, acid, alkali, and resistance to several destructive solvents. And owing to its low electrical conductivity, Bakelite is resistant to electrical currents. So these all are the special properties of Bakelite. So common properties of polymers are resistance to sunlight, moisture, acid, alkali, etc. And having this which on this and the quick mold and very smooth. Molding can be obtained from this polymer. Bakelite molding are heat resistance and scratch resistance. Owing to low electrical conductivity, Bakelite is resistant to electric currents. Now the applications of this Bakelites are, it is used to making electrical insulated parts like switches, plugs, switchboards, etc. And it making molded articles like telephone parts, cabinets of radio and television. As an anion exchange in water purification by ion exchange method in boilers. So you see in the ion exchange process, we are using the cation exchange resin and anion exchange resin. In that we are using the Bakelite as an adhesive binding for the grinding wheels. And in paints and varnishes, these Bakelites are mainly we are using paints and varnishes. These making bearing used propeller shafts, paper industry and rolling mills. So these all are the applications about the Bakelite. So Bakelite is mainly we are used for the electrical insulating parts like switches, plugs, switchboards, and telephone parts, radio and television. And this also used in anion exchanges in water purifier, that is ion exchange process we are using. And this here mainly we are used in paints and varnishes, making bearing used propeller shafts, paper industries, rolls, etc. Okay, this is about the properties and applications about phenol formaldehyde resin or Bakelite. So in the examination point of view, either PVC or Teflon or Nylon 6 or Bakelite. So among these four topics, so whatever we discussed now, types of polymerization, types of plastics, compounding of plastics, preparation, properties and applications of PVC, Teflon, Nylon 6 and Bakelite. So these are the four questions. After one more question is there, biodegradable polymer. On Monday we'll complete the half of the chapter. Okay. Next class onwards we'll start the only revision only. Okay. If you have any doubts, please raise your hand. So before that, you have to write down the preparation of Bakelite. So the structures, right, and all of you in your classwork, you write down the preparation of Bakelite. Okay.